This is a computer. Perhaps not the mind-blowing statement it once would have been, not in today's modern era of cell phones, but back in my day, if you had said something like that, people would look at you as if you had your head screwed on backwards. This is an Arduino Uno. Uno is the word for one in the Spanish and similar languages, and Arduino is a company based in Italy who makes these little devices, these little boards, for hobbyist reasons. They are nicely low-powered but still powerful, and they're easy to embed in other things. It's fairly easy to program this thing using just a USB cable and a computer, or a phone, and you can stick it in whatever you want, screw it down, and you have a computing device. So what's the reason for using something like this? First of all, fun. Let's just get that one out of the way, because fun is always valid. If you want to do something, then it's worth doing. But also, it is useful as an embedded device. A custom-engineered board for a particular purpose is of course going to be better suited and cheaper in mass production. But this is not for mass production. This is for prototyping. This is for hobby efforts. This is for temporary devices. This is for learning. And it's also useful for one-offs, where you have a particular device engineered to your particular needs at this particular time. Something for which mass production doesn't even apply. Something that makes custom engineering an entire device, or kiosk even, for a single purpose, economic and practical. Now, there are plenty of channels on this site and elsewhere dedicated to random hobbyist projects with the Arduino, and I'm not going to be one of them. I have specific things I want to use it for, and I want to mess around and have fun, but this is, at its core, a fundamentals channel. We start small and build up, like Legos. I want to build my knowledge like that. I want to build my devices like that. The point is not to create a robot by sticking in a couple boards and writing some code. If what you really want in life is a robot, then that's the great way to do it. In fact, you can probably download the code for a robot right now and just start tweaking it to your desires. If all you care about is the end result, get yourself an Arduino or a Raspberry Pi or some other similar device and have at it. But I'm much more interested in the learning, the building, understanding why something works piece by piece. The Arduino, in this case, is just a tool for me. You see, I want to make an oscilloscope. Now, I would buy an oscilloscope except for two reasons. One, it's expensive. Even the crappy ones are expensive. Unlike my cheap little Chinese power supply that works just fine but has very few features. Or my little multimeters that are nicely engineered but only do a couple things, which is all I need them to. An oscilloscope, you don't get a good, cheap oscilloscope. Keysight oscilloscopes does seem to make one that looks good. I see good reviews about it, but it's still multiple hundreds of dollars. At some point, I'm sure I will buy one. But right now, I can kill two birds with one stone. I can make my own, which obviously won't be a good oscilloscope, but the other bird is, it will be a great learning experience. And besides, I've already looked it up, and the code is simple and already online, so it's not even going to be a long, difficult project. And I'm mostly interested in the oscilloscope for measuring things like alternating current, such as when I make my own transformer, when I make my own generator and motor, and I want to be able to test them. Even if I were to use it to measure wall power, which I won't, unless I've used a step-down transformer to turn it into something small and reasonable first, but our wall power runs at 60 Hertz, so you only need to be able to measure 120 times a second, according to the Nyquist-Shannon principle, I believe it's called. You only need to sample at that frequency, double the actual frequency, to be able to get your signal. And the Arduino, with simple software that's just doing reading and writing, can manage around 1 to 2,000. So it'll be plenty. As I said, it's not going to be a proper oscilloscope, but it will be one, and I will have made it. Well, that and the guy who wrote the code, which I will shamelessly copy. Now it's funny story time. So I decided to order an Arduino, and they're not expensive. And then, next to the search results, I saw a kit of stuff designed for the Arduino. It's made by Elgu, don't ask me. But it's got LED strips, and it's got speakers, and it's got a couple motors, and a whole bunch of wires. Great wires. It's got segmented displays. It apparently has a ton of resistors, I just noticed, which is unsurprising, but I already had a whole bunch of resistors. It has a rocker switch if you want to make a joystick for a gamepad. It has all kinds of stuff, and there's different tiers. It even has a silly little fan. I don't know what that's made out of, but it's floppy. But the point is, it was barely more expensive than the Arduino for this whole kit. I looked at the parts inside, and the parts themselves were barely less than the price of the kit. And here it comes with a 9-volt battery, which is already a couple bucks. So it was certainly worth the money all on its own. So I said, okay, I got an Arduino and an Arduino kit. Lo and behold, apparently I hadn't read the description quite well enough, because when I opened the kit, I found, amongst other things, an Arduino. So I have 2 of them. But here's the thing. The Arduino platform, so you may be familiar with patents and such, licensing, royalties. The Arduino platform is the equivalent of open source for patents. They designed it, the Arduino company designed these boards, and then they just put them out there with no notable licensing required beyond basic terms, but anyone, anywhere, is allowed to just make one. And so they did. And it's pretty much an exact copy. And there are ones that aren't exact copies. But here's the trick. I decided to compare them. So you've got the Arduino Uno directly from Italy, and then you've got the Elegoo Uno R3. And again, they're identical, except, of course, this one's made in Italy, and this one's made in China. Oh, here we go. In my careful inspection, I have noticed that there are 2, what I think are capacitors, and I'm not sure because they're very small. But this one is identical in size, in shape, in where the pins are, in every single respect, even in the initial programming, except for these 2 tiny little pieces. So I've been using the Chinese one for testing things like power, so that I make sure the genuine one stays good in case I do something wrong. So a happy little accident, as it were. Now, this is obviously not a one video topic, so we'll finish off today just discussing how to power these things. So they have multiple options. This one might be easier to see for contrast. So you have, first of all, your USB plug. This is the one that I've usually seen attached to printers. And my little Arduino kit came with a cable. This is the preferred method of powering one for 2 reasons. One, it's already regulated. Your computer or your little USB power brick or whatever is already putting out a nice, clean, regular, standard USB 5-volt power. So this board doesn't have to do anything with it. It sucks it in and uses it, and it goes on its merry way. And I will demonstrate with this power brick. It's the same for a computer. You just plug in the USB, then plug it in here, and plug it in here, and now you have your powered Arduino. And the default programming is basically, hey, you haven't told me anything to do, so I'll just sit here and blink. The other reason that that is the preferred method is you've plugged it in by USB to a computer, you also use that USB line to program it. It's got a little miniature operating system, a BIOS essentially, on there that can read and write from the computer. So you plug it in, you power it, and you're also communicating with it. Now, it can also take other types of power, and the other types of power all go through what's called a linear voltage regulator, which essentially, you want 5 volts, but the demand on the circuit can go higher and lower and higher and lower. So if you were to just provide 5 volts, then sometimes it would stutter and die out, and sometimes it would go over, and it wouldn't be very good for the circuitry, and it would kind of, well, sometimes it wouldn't be able to power itself in the middle of trying to do something. So you actually give it more voltage than it actually needs. In this case, it wants 5 volts, so the manual recommends 7 to 12. And from what I've seen, 7 to 8 is just about nice. The way a linear voltage regulator works is there's more power available coming through it than it needs, so it converts the excess to heat. And anytime there's a higher draw on the system, it's just converting less into heat. If you're giving it enough power, it's always converting at least a little bit to heat. This is wasteful, but it's much smoother. A switching power supply, rather than wasting power, actually turns the power on and off really rapidly. That's why it's called switching. It's like a light switch, on and off. And it does it so fast that the circuit works just fine, but it's not smooth. And you can smooth it out with capacitors a little bit, but it's still not as good as a nice linear supply. And even a linear supply is not as nice as a battery. A battery is the best you get. But a battery is not the same convenience as plugging it into the wall. So while a linear voltage regulator is wasteful, it's also nicer to use. So I have here, first of all, my actual power supply, which I have set at 5 volts, and I will now plug in to the Arduino. The black line is negative, and there's a pin labeled ground. We've had this conversation. It's not ground. But when you see ground on a DC system, that's your negative terminal. Try not to think about it too much. So we plug that into ground. Notice that I have my current set at 0 when I'm working with it to make sure that nothing is actually happening. And my red pin, which is my positive, goes into VIN, voltage in. You also might see VCC. There's other abbreviations as well, but in this case it's VIN, which is a fairly reasonable name. And now I will give it as much current as it wants. Let's give it an amp. And of course it won't take an amp. It's taking 31 milliamps. And it seems to be functional, and right now it is, because, this is a nice stable load. It's not going up and down. Let me turn it up to 6 volts. And you'll notice it's actually going up and down a little bit. It's kind of where it wants to be, it's kind of not. The linear voltage regulator, basically when it's at 5 volts, it's not really doing anything. It's kind of passing through, and you're not really regulating the voltage. Once you go up a little above, it starts working. A linear voltage regulator requires a higher input than its output. So right now, it's actually fluctuating crazily as the LED turns on and off. But if I turn it up one more notch, it stabilizes. Nice 50 milliamps. Everything seems great. So now let's turn it up to 9. And it's still barely fluctuating, tiny bit. We're talking, a couple hundred microamps or less as the LED is fluctuating, but it's staying nice and stable at 9. So that's the linear voltage regulator in action. If I were to turn this down to, let's say, 4 volts, you'll notice the thing stops blinking. It's receiving power, but it's really not working. 5 is what it requires to function. Turn the current down, wait for it to subside, and there you go. Now I have another mechanism of powering it, which is called a barrel jack. That barrel jack right there. You may have seen these in your devices. It's a circular pin, maybe hard to see on this poor excuse for a camera, but it's basically a hollow cylinder, and you've got a little black ring that's your insulator. You've got inside is a conductor and outside is a conductor. There's your 2 pins. In this case, the devices generally work on what's called center positive, which means inside is positive. And if you were to look on a better camera, you would see there is a pin inside this hole that goes inside and that connects to the positive terminal. And this wall wart, it's called a wall wart, is rated at 9 volts output, a maximum of 650 milliamps. Well, we were drawing 50 at most, so it's going to be plenty. Even at load, if you draw, upwards of 100 milliamps, you're starting to fry your Arduino. These components are made to be inexpensive, compact, and easily replaceable. They're not meant to take huge loads. This is not an industrial device. This is a hobbyist device. And this is an embedded device, which is designed for drawing low amounts of power because it's probably running on a few batteries that you want to last for months. People put up with their laptops having battery lives as little as 3 hours. They're not going to do that for their cell phones. So anyway, the wall wart plugs into the wall, or in this case, an extension cord. And it has a handy-dandy little light, I got this from SparkFun, that says, hey, I'm plugged in. This is useful for when you are doing diagnostics on your system. If you call tech support, the first thing they ask is it plugged in? There's a reason for that, and I have experienced it too. So that way you can just look at the light and not worry about the entire thing here. You have eliminated that from your troubleshooting, and now you can figure out why else your thing doesn't work. So all we do is plug in the barrel jack, and of course it turns on. This is supplying 9 volts, just like that was, and it's being brought down to 5. And you're not really going to feel that much heat from it, not at 50 milliamps, but eventually it'll make some heat, just a little bit. There's not even any heat sinks on it. It won't be anything to write home about, but there you go with your barrel jack. So again, that's connecting to the linear voltage regulator. So now that we've got it turning on, we should actually do something with it another day. So like I said, this is not going to be Arduino channel number 8257. The Arduino is just one piece of my toolbox, and we will be exploring all of the pieces. But until then, be seeing you.